rationalizing the denominator. Let's suppose that you want to do 3 divided by square root of 2. And you want to know the approximate value of this. Well, despite the fact that you can just check this with a calculator, it's often nice to have these values memorized. Square root of 2 is approximately 1.4. Square root of 3 is approximately 1.7. And square root of 5 is approximately 2.2. If you take physics or some other engineering courses, if you may, these values often come up, and knowing these values by heart can quickly enable you to check if your answer is correct or not. So it's good to know these values. I actually know a little bit more than that. So I know that square root of 2 is 1.414 something, and square root of 3 is 1.732. And so if I want to know 3 divided by square root of 2, I would divide 3 by 1.414. But this is not so pleasant to do. I mean, trying to divide 3 as 3.000, and then you say, okay, so I put twice of this is 2.81828, and then you have to subtract, and 0.172, and then I guess I can get 2.1, and then so on. But this is not something that you would want to do. So let's see, is there any better way? Of course the quickest way would be to just punch this into the calculator, but let's just assume that we live in an age where we don't have a calculator. In those days, what people did was the following. They said, well, if you multiply square root of 2 top and bottom, and by the way, you can always do this, you can multiply any fraction by any number you want, as long as you multiply the same thing top and bottom. So I choose to multiply square root of 2 top and bottom, and that's 3 times radical 2 over square root of 2 squared. And if you take the square of the square root, they cancel. So you end up with the square root of 2 divided by 2. And this actually is much easier to calculate than trying to divide 3 by 1.414, because square root of 2 is 1.414. So if you multiply by 3, actually let's just say 3 times, if you divide 1.414, so square root of 2 is about 1.414, and you divide by 2, that's about 3 times 0.707, and then 3 times 7 is 21, so it's 2.121. Okay, so you can see that this form is better than this form, and we call this as rationalizing the denominator, because the denominator is now an integer. What's a rational number? Rational number is when you have an integer over an integer. That's called the rational number. Of course, this bottom one cannot be 0. But if you have integer over integer, and that's a rational number, this is not quite a rational number because this square root of 2 is not an integer, but at least the denominator has been rationalized. So that's the terminology people use. Now you might say, okay, fine, we have something called rationalizing the denominator. Why do we still have to learn it? Because nowadays you can just use a calculator. And even more strange is that if you were to evaluate this using calculator, 3 over radical 2 is easier to plug into a calculator than trying to do 3 times square root of 2 and then divide by 2. However, in the modern age, when we do have the calculator, there still is some need to know how to rationalize the denominator, because I mean, most of you will take pre-calculus, Math 90, and there you learn trigonometry. And in trigonometry, often numbers come out in the ratio of radicals. So for example, if you calculate tangent of 30 degrees, well, some of you actually took trigonometry, so you would know what I mean, but even if you didn't know what this meant, I just want to show you what happens there. Often you would get this value as the tangent of 30 degrees, but then if you check with the textbook or the answer sheet, you will see that they might write it as radical 3 over 3. And those who do not know rationalizing the denominator will have no idea how this turns into that. But people who do know rationalizing the denominator would say, well, this is the same thing as 1 over radical 3, and you multiply radical 3 top and bottom. Then you would get radical 3 on top and radical 3 squared on the bottom. That's just 3, so it is indeed equal to square root of 3 over 3. So that's why rationalizing the denominator is still a useful thing to know in this age of calculators. Okay. Now, so you will be asked to rationalize the denominator, and actually there's a challenging example where you have to divide when you have a rationalizing the denominator question, when you're dividing by not just a square root, but another mix of a usual number and a square root. In this case, how do we rationalize the denominator? And this is actually a very interesting question, because not only you learn how to rationalize the denominator, but you also see that there are several things that you can try that doesn't work, and it will be a learning experience for more algebra. Okay. Okay, so first I want to show you how this can fail. So failures. Number one attempt would be you see square root of 2 and say, okay, maybe what we need to do is multiply square root of 2 top and bottom, and the top will be 3 radical 2 over square root of 2 will be multiplied like that, right? So you get 2 radical 2 minus square root of 2 squared, and as we wanted, you have square root of 2 squared, so these two squares cancel, and you get 3 square root of 2 over 2 radical 2 minus 2. However, this is not so desirable because you still have a square root under the radical, so the denominator is not fully under the fraction, I meant. So the denominator is not fully rationalized. So this is no good. And then the second attempt might be that you've seen so many examples where you just multiply whatever that's in the denominator. So maybe what we want to do is multiply 2 minus square root of 2 top and bottom, right? And unfortunately, people think that this would do the trick, and that's because a lot of us will think that 2 minus square root of 2 is like 2 squared minus radical 2 squared, or maybe some people remember that minus becomes plus when you square. So they believe in one of the two versions, which is not true. Okay. See, to really see why this is not a good idea, you should actually calculate this, but because this is two terms and you're squaring it, you really need to do FOIL. So let's see what FOIL does here. 2 times 2 is 4. 2 times square root of 2, that's minus 2 radical 2. 2 times square root of 2, that's minus 2 radical 2. Radical 2 times radical 2, that's plus radical 2 squared. And you get 4. These are like terms, that's 4 minus radical 2 plus 2. And you get 6 minus 4 radical 2. So if you did this, then the top would be 6 minus 3 radical 2, but the bottom is still 6 minus 4 radical 2. So you still have the square root inside or under the fraction, and that's not desirable. Okay, so if you're still wondering why this is equal to that, hopefully you may remember the following formula. A minus b squared is a squared minus 2ab plus b squared. Okay, if you don't, you should memorize this because it's one of the important formulas. And if you have 2 and minus square root of 2, 2 minus square root of 2, according to this formula here, it would be 2 squared minus 2 times 2 times radical 2 plus square root of 2 squared. So it's 4 minus 4 radical 2 plus 2. So it's exactly this. So there will be another way to verify that indeed the denominator will still have a square root. Okay, so if both fail, then what can we actually use? Well, we use the following fact. There's something called difference of two squares formula, which is, and this has a nice acronym, it's DOTS, dots. Okay, so the dots formula says if you have one thing squared minus another thing squared, that's same as a minus b times a plus b. It's a product of the difference and the sum. And this is exactly what we want if we were to divide 3 by 2 minus square root of 2. Since if you think of a as 2 and b as square root of 2, then this formula inspires us to multiply a plus b. So what you want to multiply is 2 plus radical 2 top and bottom. And these multiply, you get 6 plus 3 radical 2. 2 times 2 is 4. Square root of 2 times square root of 2 is 2. Oh, I should really do the following. Let's apply this formula. So it says square the first minus square the second. So it's square the first minus square the second. Okay, that's what the dots formula say. And if you're curious to know why this is true, then you can just FOIL this out and you'll see that the cross term will cancel. A times a will be a squared, a times b will be plus ab, and then minus ba minus b squared, and then ab minus ba, they're the same thing, so they cancel and you end up with a squared minus b squared. So indeed this is true, and if you use this formula you get 2 squared minus square root of 2 square root of 2 squared, and they cancel, and therefore you get 6 plus 3 radical 2 over 4 minus 2, which is 2, so the answer will be 6 plus 3 radical 2 over 2. So that's how you rationalize the denominator.